So today we are going to talk about principle of homogeneity. So principle of homogeneity. I'm gonna tell you the statement and give you an example so that it's crystal clear for you. Okay. So it states that it states that comma inverted comma dimension of each every each and every term on either side of a correct physical relation are always same. So that's the statement. I don't know what that means, but that's the statement. So in an example, in a relation, suppose A is equals to B plus C. So here the dimension of A, B and C must be same. So when I look at this, I think of what the is going on. So I don't have any idea or I don't understand what it's saying. So let's think about it pretty easily. Suppose I said add 1 kilogram apples plus 1 kilogram oranges. Let's say 2 kilogram. Why not? Let's make the math complicated because we are a gangster, right? So here, so if I asked you what would be the total mass of the system now, if we mix the apples and the potatoes, we will get 3 kilograms. So what this tells, so what we understand is if the units are same, the value in front of it doesn't matter. You can add it or subtract it since addition and subtraction are literally the same thing. If I say minus 2 or plus 2, instead of 2, so let's put a bracket in 2. If I wrote minus 2, it will still be addition. It will be 1 plus minus 2. So addition and subtraction are basically same. What I'm trying to say is 1 minus 2 is basically 1 plus minus 2. So you're just doing addition. It's just glorified addition. Subtraction is just glorified addition. That's why it works the same for addition as well as subtraction. Okay, so now let's take another thing. Suppose I said add 1 kilogram. If I said add 1 kilogram steel with 1 meter rod, you would be like, what the are you talking about, right? Because it does not make sense. This is not a correct relation, which we say as, which is not a as you can see here, not a correct physical relation. So now, so this is very much wrong, whereas this is correct. So we know about two things. Number one, adding the same units, it's possible, right? And adding different units is not possible. But adding units which are of same physical quantity is possible. For example, if I added 1 kilogram plus 1 gram, it will give me something, because 1 kilogram can be written as 1000 grams, or I can convert the gram into kilogram. I'm doing it so that it will be easier for me to calculate. So we can write it as 1001 gram or 1.001 kilogram. So they are basically the same thing, right? So that's why you can actually add different units, but it has to be of the same physical quantity. Okay, another thing, what another thing is the units that we add over here, if they are correct, it will be the same unit in the other side of the equation. So here 3 kg. And also the final thing I want to tell you is dividing units or multiplying units does not matter, it works. For example, here we have force, which is mass times acceleration. The unit of mass is kilogram, and the unit of acceleration is meter per second square, and you write it as kilogram meter per second square. So as you can see here, you can multiply different units. And also, let's check out velocity. Velocity is displacement upon time. So actually this would be speed, since we are not writing vector sign, but we don't care about that right now. I told you. So now the unit of distance is meter and of time is second, so it will be meter per second. This works, which means that dividing or multiplying units does not matter. It works. I hope you understand that. And actually I can't write it exactly like this. I have to say it means that, but we are just trying to understand the concept. We are not going pure very much scientifically about it. So if I write it like this, it will be much more easier, or it will be technically more correct. So now let's get back to the original thing. So as you can see here, in a relation a is equals to b plus c, since b plus a equals to b plus c is a correct physical relation, so if you want to write, you can write correct physical relation, because this could be a wrong physical relation. We are not taking it by that context, but it could be, right? And which would mean that the dimension would not be same, but we must make it same. That's why we are taking it as a correct physical relation. So think about it. B and C, if you're adding them, they must have the same unit. So B and C must have the same unit also, which means the dimension must be same. Since they have the same unit, they must have the same dimension. When I'm saying unit, I mean to say the unit must be a unit of physical quantity. I'm not stating that a kilogram or a gram are the same thing. I'm just stating that kilogram and grams are units of mass. So when I'm saying same unit, I'm trying to tell you that it is the same unit. It is a unit of same physical quantity. So don't get confused by my wording. Okay. So B and C must be have the same dimension. Since here is dimension, let's say it's dimension. So which means E also has the same dimension, because we are adding them. So as you can see here, you can add kilogram and gram has the same dimension, if you know that. That's why it's still correct to write like this. So I hope you understood what principle of homogeneity means. So let's look at it once more. Dimension of each and every term on either side of correct physical relation are always same, because when you're adding or subtracting, they must be the same quantity. When you're multiplying, dividing, it does not matter, but when you're adding, subtracting, equating, they must be equal. So that's the gist of it. I hope you understand the video. In the next lecture, we are going to talk about the types of physical quantities, which is also I don't know if it's important. I'm just going to teach it to you because I like it. Okay, enjoy.